Hey guys, I'm back. So today I'm going to be talking about how bosons actually mediate a force, or how they control that force. So you've heard the bosons mediate a force. They act on stuff to mediate the force, basically. So how do they actually do that? So I'm going to be referring to a video that doesn't exist at this point. So you're going to have to wait a few days to watch it. It's going to be about the Heisenberg uncertainty principle. To understand certain parts of this video, you're going to need to watch that video, which is coming out later. Just a heads up, unless you already understand those things, in which case you're good. So this is how bosons actually mediate a force. So due to the Heisenberg uncertainty principle, particles like this electron will basically release particles, bosons, so like photons, gluons, mesons, WZ, Higgs maybe, if due to the Heisenberg uncertainty principle. So they'll release it, and this counters the laws of conservation of mass and energy, but then it immediately gets reabsorbed by the particle because it's not real. It's called a virtual particle. So particles like electrons are always emitting out, electrons, since they take part in mostly the electromagnetic force, they're always emitting out photons. So electrons are just always emitting out photons, but then the photons are always getting reabsorbed back into the electron very quickly because they're not real, they're virtual, so they have to get reabsorbed. So if we have like this, we have two electrons, right? We have the one right here and one right here. Again, this is a green screen, so I'm not pointing exactly to the electrons, whatever. So these electrons are going to emit and reabsorb photons, a lot of photons, so they're going to have this virtual cloud of photons around them. And so when these two electrons get closer and closer together, at one point, an electron from one is going to be emitted by this a photon from this electron is going to be emitted, but instead of getting reabsorbed by this electron, and by the way, an electron emitting a photon and then the photon getting reabsorbed does nothing. It means nothing. It has no effect on anything. So then that's happening for this electron and this electron. And when this electron releases a photon that instead of getting absorbed back by this electron, gets absorbed by this electron, that is the photon you'll see in Feynman diagrams such as this. And that photon is what we call mediating the force. So basically the photon went between the electrons and it's going to change their momentum or something like that, send them in a different direction, because that photon connected the two for a second, because it went out from one, a virtual photon went out from one and went into the other. So if you can see, if we have two electrons and they sort of come up like this and they each have their cloud of virtual photons, they're getting emitted and reabsorbed, and then they're going to get close enough that a photon from one is going to be emitted and absorbed by the other, they're going to change their momentum and go a different way, because that photon transferred energy, or the electromagnetic force between them. The electrons are going to be repelled because they each have an opposite force. So the photon emitted by one is going to push the other away, and so it's going to push the one that emitted it away and push the one that received it away. So that's one example. We could do another one, like we could do, say we have a proton here, and it's constantly emitting mesons that are getting reabsorbed by the proton. Mesons will transfer the strong force, just like gluons. And so say we have a second proton right here, and we're in the nucleus of the atom. If these protons are at a great enough distance, they're also, since protons have a positive one charge, they're going to be emitting photons. And when the protons are too far away for the mesons to interact, like I just described, the photons are going to interact, and it's going to push the protons away, just like I said with the electrons before. So like if we have two protons here and the photons are coming out, and the mesons have a much shorter range because I'll explain that in the next video, but it's basically because they're much more massive and the strong force is much stronger than the electromagnetic force, to summarize. So the protons are going to be emitting these photons and the mesons, but the mesons have a much shorter range, and when they get close enough that the photons interact, that's going to transfer the electromagnetic force, and they're going to repel each other because they have the same charge, obviously. But say they're close enough that the mesons will interact. A meson that is just spontaneously emitted by one is going to then, instead of coming right back to the same proton, it's going to be absorbed by the other one, and then since the strong force attracts the protons, they're going to get attracted together. Because that's actually how bosons will actually mediate a force. They'll any particle that takes part in the force will emit the boson that carries the force, And then usually those bosons just get sucked right back. I don't want to say sucked, but they'll get reabsorbed. It's the right word. Reabsorbed back into the particle. Sometimes when two particles are close enough together, one that's just spontaneously emitted by one particle, the boson that's spontaneously emitted by one particle will be absorbed by the second particle, and then that's what you call transferring the force. So the thing that you would expect to happen would happen. So if they have the opposite charge, they're going to get repelled by the particle that went between them. If they have the same charge, they're going to get attracted by the particle that went between them. And remember, the particles that they're emitting and getting reabsorbed are always bosons, because bosons carry forces. Fermions can't carry forces, only bosons can. So I hope you learned how bosons actually carry the force, and I'll leave you with a little animation of sorts that I've been showing throughout the whole video. So enjoy it.